So in this video I'm going to be solving a problem from my friend's homework. So Kaz, this video is for you. So it says find the arc length of this curve. It's not a function because this y square will yield to two different functions you'll see in a second. 4x going between 0 and 2 and positive values of y. So to find arc length, let's write down our arc length formula, which goes from, well, in this case, the x values are 0 and 2, so let's just write that there, of the square root of 1 plus the derivative of y squared dx. So for this problem, we're going to find the derivative of y. But first, let's find y itself. So this guy, if we solve for y, we gotta take the square root of both sides, and that's going to give us the square root of y squared equals the square root of 4x plus 4 quantity cubed, and then so this yields the absolute value of y equals, so the square root of this guy is 2 times x plus 4 to the power of 3 halves. So now, since we want the positive values of y, we gotta just consider the plus side of this equation. So y is 2x plus 4 to the power of 3 halves, right? Because if we are to drop the absolute values here, we would get plus or minus. But since we only want the positive y values for this function, we just take the positive side of this, the positive version of this. So now that we have this function, we can get the derivative. So the derivative is, we're going to calculate here, of this is, well, constants. So constants go outside and then multiply by 3 halves. So 2 times 3 halves of x plus 4 of 3 halves minus 1 is 1 half. That equals 3 times square root of x plus 4. Yeah, that's x plus 4 to the 1 half is the same as this. So now if we apply this formula, well, arc length is integral from 0 to 2 of the square root of 1 plus the derivative squared. So here's our derivative, and we're going to square this to use our formula. So this equals, I'm going to put this a little bit on top, integral from 0 to 2 of square root of 1 plus 3 squared is 9, square root of x plus 4, and the square 2 here cancel out to get x plus 4, everything under the square root dx. This equals the integral from 0 to 2 of the square root of, so let's actually combine all of this, and you'll see how this will nicely become a linear function instead of a root. So if we combine this, we get 9x plus 37 dx. So this is here's a technique for integration that you gotta know from your first semester of calculus. Is like when you have a linear function, so like something times x plus something, a constant, you let u be precisely what is inside the integral, and then this yields u equals 9 dx. And this is nice because then our integral becomes just well, integral and then square root of u, and dx is simply du over 9. So let's put that 1 over 9 outside. And, well, of course, bounds of integration, that goes from, well, if you plug in 0 here, right, corresponding to this bound of integration, if you plug in 0, you get 0 plus 37, 37. And if you plug in 2, you get 81. I was squaring 9. 9 times 2 is 18, plus 37 is, well, 47, 55. Right, I always like to double check my math. So 18 plus 37 is like 37 plus 20, 57 minus 2 is 55. Okay, good, good. Oh, can you see my thumbs up? Yep, good. So now this is very nice, right? Because this is just 1 over 9, 37, 55, u to the 1/2. So we can apply directly our power rule for integration, so that's 1 over 9. And then if we apply the power rule, this becomes a, what's 1/2 plus 1? 3/2, 2/3. 3/2 going from 37 to 55. And then this is a product of fraction, so that's 2 over 27 of the fundamental theorem of calculus applied to these two on this function. So that's just what is that equal to? 55 to the 3/2 minus 37 to the 3/2, and that is the arc length of this function over here. Well, okay, again, this is not a function, but just the part where y is greater than 0. So it's actually this one over here. Yes, we just calculated the arc length of this function from 0 to 2, and we got this answer over here. Thank you.